Good morning, everyone. My name is Rumpel Thompson, bringing you worldwide news. Right now, the temperature is 78.937 degrees Fahrenheit here in Storybrooke, Maine, with a high of 90 for this afternoon and a 37.25756 chance of showers. As you know, we are the trendsetters of news, and we are starting a Throwback Thursday. We're going to talk about the greenhouse effect, X-rays, the lives of some important scientists. So let's go to Tabitha Smith to interview an important scientist to help discover the greenhouse effect.
Thank you, Rumpel. Hello, here I am with the one and only Joseph Fourier. Can you tell me a little bit about yourself, what backgrounds you came from?
Hi, I want to thank you for allowing me to be here today with you. Yes, I was born in March 21st, 1768 in Auxerre, French. I am the 12th of 15 Catholic children. I attended a local military school taught by monks starting at a young age, I became intrigued with science and mathematics. I became so interested with mathematics that I decided to become a mathematics teacher and came back to teach at the school I attended.
Oh, so did you teach there until your retirement?
No. While I was teaching and the French Revolution was going on, I became more and more interested in it. Within a few years after I began teaching, I decided to join Napoleon.
Oh, Napoleon!
Yeah, we went on a conquest to Egypt. And while I was in Egypt. And while I was there, I did many things, such as setting up educational facilities, carried out archaeological explorations, and there I was put in charge of collecting the scientific and literary discoveries and was appointed as the secretary of one of the institutes there.
Whew, wow, that sounds really interesting. Please tell me more. Tell me more.
Alright, well, you see, I spent 3 years in Egypt. 3. And while I was there, I was involved in many things. But I came to realize the partial differential equation for conductive diffusion of heat, and I created many mathematical equations.
Unbelievable! So tell me, out of all the discoveries you made, which one impacts you the most?
Here, let me take you to my laboratory to show you.
Wow, I am so honored. Let's go.
Over here, come on.
Wow.
So here we are at my studio.
Oh, very nice, very nice.
Thank you. As you see, all this science.
Yeah, beautiful. It's like a museum, but for science.
You know.
Yeah, anyways. Wow, so here we are at Dr. Fourier's lab, so he can teach us a little bit about his accomplishments.
Yes, indeed. Okay, well, you see, my greatest discovery is attributed to the discovery of the greenhouse effect. In my free time while I was in Egypt, I like to find the science behind everything. And so the temperatures on Earth caused to interest me, you see? And so I began to explore, and I came to the conclusion that taking into consideration the size and distance from the sun to the Earth should be much colder than what it is. With all this taken into consideration, I concluded that a large portion of the additional heat that the planet received was due to the interstellar radiation. My concept that the Earth's atmosphere acted as an insulator is known as the greenhouse effect.
Oh, greenhouse effect! Wow! I've heard that. You're a genius.
Thank you. But I have to say, I couldn't have done it without Saussure's experiment. It was through his apparatus as a means of measuring the intensity of solar radiation that I was able to make the connection that gases in the atmosphere could form a stable barrier like the glass pains in his experiment.
Unbelievable. Okay, thank you so much for giving us your time. I couldn't, it gave us such an insight in your discovery. Thank you. All right, well, this is Tabitha Smith signing out. Now back to you in the studio.
Thank you, Tabitha. And now, as a special part of today's new segment, we have an exclusive excerpt from the Bill Nye the Science Guy, the Physics Guy program. Science of X-rays.
What is an X-ray?
How is it used in today's society?
Why was its discovery so revolutionary?
All these questions coming up next.
X-ray case study.
Bill Nye the Science Guy. Science rules. Bill Nye the Science Guy.
Hey there. Cheese. Oh wait, this is closed. Cheese. Wilhelm Conrad Röntgen, the German who accidentally discovered X-rays in 1845, was quite fond of photography. It was this hobby of photography combined with physics that led him to the discovery of X-rays. So what exactly is an X-ray? Let's find out. So first, let's look at the electromagnetic spectrum. We'll see that above visible light there is ultraviolet light and then X-rays. Have you ever seen a flashlight put through your fingers and see how light travels through your skin? X-ray travel even more effectively, but do not travel to ground. X-rays are electromagnetic radiation that differentially penetrate structures within the body and create images of these structures on a photographic film or a fluorescent screen. These images are called diagnostic X-rays. So basically, they are pictures of some parts of your body not visible to the eye. Diagnostic X-rays are useful in detecting abnormalities within your body. They are a painless, non-invasive way to help diagnose problems such as broken bones, tumors, dental decay, and the presence of foreign bodies. So then there's the question, how do doctors do it? Well, the doctors place the patient between the X-ray emitter and the special film where he exposes the patient briefly to X-rays. The X-rays pass through the patient to the film, except not the patient's bones. So on the film, the areas that went through the skin, the areas where the X-rays went through the skin, are reflected as black, where the areas where the bone was absorbed the light turn white. So this way, a doctor can see what's inside your body. Actually, Wilhelm Conrad Röntgen, the German who discovered X-rays, actually got a Nobel Prize. So, pretty good.
Thanks, Bill. That sums up our program for today. Hope you enjoyed today's news. And hopefully we'll see you tomorrow.
Hopefully, that sounds like...
Hey there!
68 in Auxerre, France.
68 in Auxerre, France.